Alright, hello everybody. So this is going to be a talk about the anatomy of graphical applications. This talk is not going to be specific to any operating system or any programming language. There's not going to be any code. It's really just the structure, the architecture, how all the pieces fit together, how they talk to each other, who talks to who initiates what, etc. And it's not about a particular application. It's not has to be a game or a GUI application. It could be any of those, basically. All right. So typical design that you're going to be seeing is you got your application layer and you got your platform abstraction layer. So say you use some library, say SDL or SFML. Something that abstracts away the vagaries and the differences between different operating systems, such that the application doesn't need to care what operating system it's running on. It's just making calls to some consistent API, and it just works, right? It can run on Linux or Mac or Windows, and the application code doesn't need to change, and it doesn't care. That sounds really great, but notice the arrow is pointing from the application to the platform abstraction layer. So the platform abstraction layer has to provide some callbacks to the application layer, such that code in the application layer can make call into the platform abstraction layer. So the party that's in charge here is the application layer, not the platform abstraction layer. And for that to be able to work, the platform abstraction layer has to implement different calls to different platform specific codes, so different code path for Mac, Linux, and Windows, etc. And then it needs to expose some callbacks to the application layer to call back into. And it can't support all the features of all the operating systems there, because some things only exist in a Mac, or some things only exist on Windows or Linux, etc. So it has to basically make some subset of all of those that kind of works across all three, or across how many other platforms it abstracts over. So it's going to be some lowest common denominator, some subset. Alright. There's a problem though. So all executables, as it turns out, are plugins. That's kind of weird to think about, but like an executable doesn't execute itself. When I say executable, it says exe here, but I'm really talking about any executable on any operating system. Linux, Macs, Android, iOS, whatever. The operating system is the thing that executes the executable in response to some command from some other executable, or from the user. So the operating system is the thing that's in charge, and it executes the executable by loading its code into memory and then invoking some function, some entry point that's already existing in the executable, and that it knows where to look for it. So when you compile a program, whatever programming language, when you compile to a specific operating system, the compiler, actually the linker, knows how to put some code into the executable that the operating system will then later know to find and call into. So the executable is exposing some callback, some function. Could be even more than one. That's usually called entry point. It's some place that the operating system, when it wants to execute executables, knows what to call. So that the code inside the executable in any program, it doesn't matter, it doesn't even have to be a graphical application. It could be a service, it could be a server in some data center, it could be a command line tool with no GUI at all. It doesn't matter, it's always the same. There's going to be some entry point, some function that the application, that the code has to expose to the operating system to call back into. Now, when it comes to graphical user interface, graphical applications, there may be even more than one callback that the applications, the code inside the executable, has to expose for the operating system to call back into. And we'll get into that. But the point is that the executable doesn't live in a vacuum. It doesn't execute itself. It plugs into an operating system so that you can say that any executable is a plugin to the operating system. It's kind of a weird concept, but that's how actually it works. Alright, so with that in mind, we can flip that around. We can say, okay, so what actually is going on here is the platform layer of the application, of the executable, is the thing that is a plugin to the operating system. So it is the thing that's going to be getting called. So it is going to be the thing that's in charge, right? So if it's a Win32, it's going to be like some Win32 code that's going to expose some entry point and maybe even some more callbacks to the operating system. And then in response to that, it's going to make some calls into the application layer that's now at the bottom. So the arrow points from the platform layer down to the application layer. So the application layer doesn't even know that there's a platform layer at all. It just exposes callbacks. So the application now becomes a plugin to the platform layer. So we have like two layers of plugins here. The platform layer is a plugin to the operating system by exposing the entry point and exposing some other functions as callbacks. And the application layer is itself a plugin to the platform layer. It exposes a bunch of callbacks to be called back into. It doesn't even know that there exists a platform layer necessarily. Okay, this way the platform at the top it can be anything. It's not limited. It doesn't have to abstract away something for anything, because it's only exposing outwardly to the operating system directly. So it only needs to expose what it knows that the operating system expects for it to expose. So it can be very specific to the operating system itself, and it can use any and all the features that it wants for that particular operating system. And the application layer doesn't even need to care that any of that is happening. All it needs to do is expose a bunch of callbacks up to the platform layer. So in this case, the platform layer is Win32, but it could be Linux, it could be Mac, and these codes could be arbitrarily different. Okay? And there is no subsetting that any of these code need to adhere to, because they can be completely separate. There could be some code that's shared, but generally speaking, it can be arbitrarily different, and there's no subsetting. It can use all the features of the native platform that it is going to be running on. Alright? Okay. So, let's go a little bit deeper and explore the architecture of this design. So we have an operating system on the left. It could be any kind of operating system. For this example, we'll assume it's Win32, but it doesn't really matter. And we have a mouse and we have a keyboard. Okay, in this case it's gonna be like a device that represent a mouse and the keyboard to the operating system. It's actually, it could be thought as the actual mouse and keyboards that are connected to the actual physical computer, but you get the idea. So, and we have a screen on the other end, something that's gonna be displaying the pixels of the window that the application, the graphical application, is displaying. Alright. And in between those, we're gonna have the platform layer. So in this case, gonna be like a Win32, say, and this is gonna basically take all the inputs from the user by keyboard and mouse, and from the operating system itself. For the operating system, it could be stuff like the window manager decided that the window now is visible, or it now is hidden by another window, or it gets minimized or maximized, etc. So there's going to be a message coming from the operating system itself, and message coming from the operating system via the operating system from the mouse and keyboard. And all of these are going to be put into some queue. This could be a queue of events or queue of messages. Different operating systems call this differently. There's all kinds of different definitions for these terms. I'm not going to get into it. There's some queue of some stuff that has happened. And the platform layer is expected to pull those events or messages from the queue. The queue itself is usually opaque. You don't even code it yourself. There's a queue and it gets filled up without you doing anything, and all you're expected to do is pull events or messages out of that queue and processes them. So there could be messages from the operating system, messages about a mouse click or a mouse move or key press or key hold or something like that. Okay. So we're gonna have this loop, and it's gonna be pulling all the messages from the queue all the time, because there's gonna be a stream of messages continuously from the operating system into the queue, and we're gonna be just looping forever until the application closes. Okay, so we need to put pixels on the screen somehow. So usually what's being done is you have some kind of a frame buffer, or just an array of bytes that represents the colors of the pixels displayed on the screen. The operating system is continuously issuing what's called paint messages every time it needs to display what the application wants to display inside the window. There's like a paint message, and our loop is gonna pick up that paint message, and it's gonna say, okay, I need to send to the operating system the pixels of the window. So it just takes whatever is in the currently in the frame buffer and just sends it back to the operating system to display in its window. Alright. On the right here, we're gonna have our engine. That's gonna be the application layer. We're gonna call it engine. For this example, it's gonna be like 2D or 3D rendering engine. Doesn't really matter. It could be like a GUI application, but for this example, it's gonna be like a render engine. So we're just gonna call it an engine for the right side. Alright, and the frame buffer itself is just, as we say, it's just an array of bytes. So there's nothing platform specific about that. So it can actually move into the engine itself, which is platform agnostic. And you notice that the arrow goes through the frame buffer, but it still gets initiated by the platform layer on the left. The portion on the right, the engine itself, doesn't initiate anything. It just exposes a frame buffer that it owns, right? Okay, so the user moves the mouse, the user uses the window, or maybe moves the window, maybe it resizes the window. Okay, so when the user resizes the window, there's gonna be an event or a message that's gonna pull into the queue that says, well, the window is resized. So we can pull this message and we see what the new size is, and we're gonna have to tell the engine, hey, there's been a resize event, and because it needs to resize the frame buffer, because the frame buffer contains all the pixels of the window. So the engine, as you can see, is just exposing a resize function, a callback, and that callback plugs into the platform layer on the left. Right? The engine itself doesn't even know or care if anything ever calls it. It just exposes this function, this callback, and in this callback, in the implementation, it does all the logic that resizes the frame buffer, etc. Okay, so we have a frame buffer. What are we drawing? Currently we're drawing nothing, so the frame buffer is empty, so we're going to have a black screen. We're going to have something that draws into the frame buffer and fills it with pixel colors, so that we'll call it the render engine. That's the rendering part of our engine. It's the thing that decides what the next frame is going to look like. Okay, so as I said, we have mouse and keyboard. Currently we're not really doing anything with it, but obviously the user needs to interact with the application. So what we want is we want the engine to have some state representing what is the current state of the mouse and the keyboard, or any other input, and it needs to expose a way for this state to be updated. So it exposes some callback that plugs into the platform layer, and that callback is the thing that's going to be updating the state of the input inside the engine on the application layer side on the right. Okay, so it exposes the input callback that plugs into the platform layer, and then whenever the platform layer decides, whenever there's a mouse or keyboard event, it calls into the callback that the engine has exposed and telling it, hey, this event happened, the mouse is pressed, the mouse is moved left to right, whatever. Okay, alright, let's start filling up the gaps between the input and the output. So we have a render engine. What is it rendering? Usually if it's a game or something that is 2D or 3D, there's like a camera or a viewport, usually both, and it's going to be rendering whatever is viewed through that camera. Okay, so the camera is going to have some coordinate system, and something needs to control it. So say it can be moved, it can be reoriented, there could be like a zoom or a dolly. So there's going to be some code that's going to be like the camera control, or something that's controlling the camera. And it's going to do that using whatever the current state of the input. It doesn't care how many times that input got updated, it just uses whatever the current state of the input is right now. That's it. Alright, so now something has to invoke all of that. So that's the last piece of the puzzle. We have some update method that's gonna kick off all that process, or evaluating the input state and updating the parameters and position orientation of the camera, and we invoking the render engine to render a new frame. And that's going to be like the the main update method or callback of the engine itself, and it's exposing it as a callback, and which plugs into the platform layer on the left, and then it's on the platform layer itself to decide when and how and at which interval to invoke that update callback. Alright, just to hammer this home, we have the whole picture now, but just to hammer this home, I can just nuke up everything is on the left, and as you can see, the engine itself doesn't even know or care about anything that's outside of it in the platform layer. It doesn't even care if there is a platform layer, and it doesn't initiate anything. It's just code that exposes a bunch of callbacks and holds a frame buffer. That's it. The thing on the left could be arbitrarily different for a different operating system, if it's a Mac or Linux or anything like that, and the engine itself doesn't care, and it doesn't need to change. It can even be something that's not even a real operating system. It could be some testing framework that's running tests to test the code of the engine and emulates it. The engine code itself, none the wiser. It doesn't even know that's happening. Alright, so that's about it. If you like what you see, what you saw, you can hit the like button, you can subscribe, and that's it. See you next time.